In this video, we'll be talking about how to find the volume of a solid of revolution using the disk method. If a region in the plane is revolved about a line, the resulting solid is the solid of revolution, and the line is called the axis of revolution. The simplest solid is a right circular cylinder or a disk, which is formed by revolving a rectangle about a line. Recall that the volume of a cylinder is volume equals pi r squared h, r being the radius of the cylinder and h is the height. Over on the side here you can see a disk or a cylinder. The radius is this distance right here from the axis up to the edge of the cylinder, and then the height would be the thickness of the disk. To find the volume of a solid of revolution, we will consider a representative rectangle. When we revolve the rectangle about the axis of revolution, it generates a representative disk. So the rectangle that we would be talking about here would be right here. If the axis of revolution is horizontal, then the formula is volume equals the integral from a to b. Notice a is the left boundary of our interval, and b is the right boundary of our interval, and then pi r squared h. R is the height or the value of the function at any given x value, and then dx is the thickness or the height of our cylinder, our disk. We can simplify this sum by pulling out the pi in front of the integral, and we have volume equals pi times the integral from a to b of f of x squared dx. If the axis of revolution is vertical, then our formula is volume equals the integral from c to d of pi f of y squared dy. F of y is our value of our function. Here's our function. So for any given y value, as we move along the interval from c to d, f of y would be the value that we get when we plug in our y value. So volume equals pi times the integral from c to d f of y squared dy. The example that we'll be doing is to find the volume of the solid formed by revolving the region bounded by the graphs of f of x equals square root of x minus 1, y equals 0, and x equals 5 about the x-axis. So let's draw a sketch first. When x equals 5, we have the square root of 4, which is 2. And when x equals 1, we have 0. So our function right here, f of x, is the square root function that looks like that. Now what we want to do is revolve this about the x-axis, so let me indicate that here. That'll look like something like that when we do it. Let me also show a representative rectangle. And then this guy when he's revolved. Be right there. So our formula that we'll be using is volume equals the integral from, in this case it's 1 to 5 of pi f of x squared dx. Now this is our f of x, and our thickness of our rectangle, let me label that, that's going to be dx. My volume then will be the integral from 1 to 5 pi and then square root of x minus 1 squared dx. I can take my pi out in front. When I square this radical, I get just x minus 1. So now we just need to do the math here. My pi is out in front. When I integrate x, I increase the exponent by 1, divide by the new exponent, so that's x squared over 2 minus, and then this will be x, and I'm evaluating from 1 to 5. And my volume equals pi. Now I'll put 5 in first, so 25 divided by 2 minus, and then I subtract from that what I get when I put in the 1. So 1 squared is 1 over 2 minus 1. Our volume equals pi times, I have 25 halves, subtract 1 half is 24 halves, which is 12 minus 5, and then this goes in and makes that plus 1. This gives me a volume of 8 pi.